Once we cast the journal entry and position to the JETB, we can move on to extracting date column data from the DF table to the journal entries. Again, given the difference in accounting practice, the accounting logic described in this series of tutorials is only for demo purposes. It might be different based on your location. Concepts covered here is meant to be minimalistic. I'm not held responsible for any errors, incomplete or misrepresented information, and or any harmful effects associated with the materials in my video. By watching this video, it's assumed that the viewers bear all the risk, both current and potential losses associated with this video. Okay, enough for disclaimer. Let's dive in. Due to its complexity, I've created a list here first. The formula you see here returns the date column value based on the JE and POS fields. The position for each JE is 1, 2, 3, 4, 5, 6, where the journal entry number is like this. And this is the index of the JETB table. This one is JE. This is the position. And this is how it looks like in your journal entry table. The date for JE1 is January 1st, right? The date for JE2 is also January 1st. POS 3 is nothing, and POS 4 is the deposit day. POS 5 is also the deposit day. POS 6 is 0, which I explained in the previous video. Let's start coding it here. We start off with a Python list for IDX, P, which is the position, in the column jetb.pos. If we return P, we'll list out all the positions from the JETB table. Oops, here I forgot the keyword enumerate, and the typo JE, which should be JETB. Also, get rid of the equal sign up front. That's the little difference when coding Python in Excel. Here, select Excel object, and you should see each position 1, 2, 3, 4, 5, 6 gets printed out, just like the POS column, right? So we know position P is just each value in the POS column. If we put index here, it will return each value along the jetb.index column. As you can see, this is the same as the jetb.index column, which starts from 0 going down 18 rows all the way to 17. Let's take a look at this part. The for loop here means for each position, 1, 2, 3, 4, 5, 6, repeating 3 times for a total of 18 rows. Each row holds the value of the result. Okay, so where is the result? It's in the DF table that we create in the previous videos. We use this for loop to look up with the row index, JE, and the column index, position, to fetch the result value in the DF table. Let's say we want to get date. There are 6 date columns in the DF table, right? Day 1, day 2, day 3, and day 6, 6 positions. So it's like date 1, 2, 3, 4, 5, 6 here. How can we make this P the position to dynamically name the lookup column based on positions 1, 2, 3, 4, 5, 6? Simply add the fstring keyword here to make it an fstring. Add a curly brace and insert the variable, which is the position P, and it will change the column name dynamically, 1, 2, 3, 4, 5, 6, and so on. In other words, we can now look up with the account position, which is this column, 1, 2, 3, 4, 5, 6, repeating for 18 rows. For each row, trace to the 6 date columns to fetch value. The column names are just date 1, 2, 3, date 4, 5, 6. Here for the row index, the index is supposed to be 0, 1, 2. Why? Because when it is 0, the JE value is 1. When it is 1, the JE value is 2. For each of the 18 rows, the first 6 rows have JE value 1, where the index is 0. So the index 0 returns JE value 1. If we want to return JE value 1, we need to put JETB table's JE column here. If we put index 0 here, it will look up with index 0 to get JE1. This number is just shifting 1, so we just minus 1 here. Control Enter, and it will be like this.